Hello everyone and welcome to one of CMG's TechBite videos. My name is Qusayl Hinay, and in this video we'll be talking about sensitivity analysis in CMOST. A brief understanding of CMOST. CMOST starts by selecting a combination of parameter values to use in a simulation. With this data, it creates a new simulation dataset by inserting these values into it, and once created, the model is simulated. Results are read from the simulation. CMOST uses information along with its optimization algorithms to determine the next set of parameter values. So our goals in sensitivity analysis are to determine which parameters have an effect on our results and how much of an effect do they have on them. And the process goes by selecting your parameters to be analyzed, for instance, porosity, and then selecting a range for that parameter to be analyzed, such as 20 to 30% for porosity, and then seeing the effect on a certain result, which is our objective function. For example, cumulative oil, MPV, oil recovery factor, and so on. There are two methodologies in CMOST for sensitivity analysis, one parameter at a time, where each parameter is analyzed independently, while remaining parameters are set to their reference value. And we also have the response surface methodology, where multiple parameters are adjusted together, then results are analyzed by fitting a response surface using polynomial equation or neural network to see its effect on our results. And lastly, a small understanding description of our dataset that will be used in the video. We'll have an 81 by 81 by 10 meter grid. We have an initially tight oil reservoir with one horizontal producer, which has fractures, hydraulic fractures. Our parameters that we're going to use for our sensitivity analysis include our matrix permeability, both in the horizontal and vertical direction, our porosity, fracture permeability, core exponents for oil and gas. All right, we'll open CMOST and create a new project. In this case, I'll call the project name Tight Oil. And I'll browse for my base data set. There we go. And what CMOST has done, it has created a project folder and has told us where that location is of that project folder. And the project file has an extension of .cmp and a project folder .cmpd, okay? And with this tick, it says to copy the base case to that project folder, okay? To make it easier that everything, including your base case, is in that new folder. So click on OK. And we're gonna create a new study, and we're gonna call it Tight Oil SA, as in for sensitivity analysis. And again, we're going to browse for our data set, and this time it's going to be in our new project folder that we just made, okay? And we're going to define our study type as sensitivity analysis, okay? And over here, it's written automatically create a master dataset .cmm to be used. So the master dataset is the same as the base dataset, however, it includes your CMOST definitions, okay? It's a template where CMOST can use for parameterization and so on. So click on OK. And you can enter your study by either by going to the tab or clicking on the icon here, okay? A brief understanding. General properties is where you can set your units. So in our case, our base data set is in SI units, so CMOST automatically sets it at SI. However, you can change it to field or lab. You can also import your field history files, which include your history data and your log files, okay? Fundamental data, or in the case of original time series, you can take your SR3 files, properties, and see them in CMOST over here. Your user-defined time series include your formulas. So for example, you have a property from your SR3 files, that you would like to see here and make a formula between them. Your property versus distance, you could see your saturation profiles by importing your log data. Okay. In our case, we're going to go to parameters, click on parameters, and I'm going to show you different ways that we can import our parameters into CMOST. So by going into Builder, clicking on the right side, we'll open our data set in Builder. Excellent. And straight away, we can choose which parameter we would like to see in our sensitivity analysis. We're going to go to matrix permeability. So under reservoir, array properties, I'm going to choose permeability I, which is our permeability in the horizontal direction. Add it, call it perm H. Okay. I'm also going to add permeability J and set it the same as permeability H by clicking on it. And then permeability H, our predefined CMOS definitions will pop up. And for permeability K, I'll add it and rename it perm V. Okay. We can also add our fracture permeabilities by going under hydraulic fractures, planar fractures, templates, and into our template parameters. And over here, under intrinsic permeability, we have a value of 20,000 millidarcy. Click on that and add it as our fracture permeability. Okay. Another option is by going under Builder Keywords and going to our rel perm tables. We have two in this case. One is for our matrix, one is for our fracture. We'll go into the matrix one. And we're going to add our core exponents for oil and gas. So if you click on the value, you can see at the bottom the variable name, the parameter name. In this case, we have exponent for oil. We're going to add it. NOG. And for gas, the same thing. NG. Okay. So any keywords that are under Builder Keywords would be regenerated as they are in either using a formula or a correlation. Okay. So once we save this file, it will be saved as a CMM, which is our master data set. So you click on OK. Yes. Okay. And now we would import it into CMOST, and we have all of our parameters. Okay. We can also create a CMOST parameter in cedit. So opening up cedit on the right side here to open up our base data set. And in this case, we would like to change porosity. So under reservoir description, if I knew the keyword, I could go to POR, which is for porosity. And in this case, in this data set, we have a constant porosity for the whole grid of 0.1. So highlight the whole, if you highlight the whole number, value of that parameter, and right click and create parameter, you could, a pop-up box will allow you to set it as a parameter for CMOST. In this case, I'll call it porosity. And we have a CMOST thread where this is the beginning of the CMOST definition and the value and the parameter name and the end of the CMOST definition. Okay? And above here, we can see the other CMOST parameters that we did in Builder. So after doing anything in cedit, in our text editor, you would save it, go out, and then import your parameter again. Another way of creating a parameter in CMOST would be inserting it in CMOST. So I would call a new parameter KV, KH ratio, which is the relationship between our vertical permeability and our horizontal permeability. And I would give it a value of 0.25. Now the next step is to give ranges to these parameters. By default, any parameter, its default value has a range of minus and plus 25%. Okay? You can change any value. So in this case, just for example, I can change do it from 10,000 to 30,000. Here I can do it from 1.5 to say 2.5. Okay? For permeability V, we're going to use it as a formula, as a source. And in that formula, we're going to use our KV-KH ratio. Okay? And that formula will be perm V equals perm H multiplied by KV-KH ratio. It's important to have it case sensitive and the same as this spelling as made here in our CMOS definitions. Okay? Just test if this works. You can click the button check for errors, and if a value comes up, it works. Okay? We also need to set a range for our KV-KH ratio, so 0.05, 0.25, or 0.5. Now that we have a range for each parameter, we're done for parameters, the parameterization section. We can go to our objective functions, and for our sensitivity analysis, we're going to enter basic simulation results. Okay? So under basic simulations results for original time series, which is our properties from our SR3 files, we can insert certain objective functions that we wish to see. For example, cumulative oil production, also our cumulative gas, production. And our base case stop means that we would like this time series to stop at the end of our base data set. Okay? Our original types are wells, and since we have only one well, we can pick it out for both of them. And the property with respect to the name of that variable. So for the first one, cumulative oil, and the second one, cumulative gas. All right? So now we have set what we would like to see our parameters affect our objective functions. Moving on to, lastly, our control center is where we like to see how our cases be run. Under engine settings, we have the study type, which is our sensitivity analysis, our engine name, either response or one parameter at a time. And dependent on how complex you want your equation to be, your model, you can choose from 3 different types of fits. And the more complex it is, the more CMOST would need more new experiments or training experiments to get that fit. By default, we have linear plus quadratic. Okay? And under simulation settings, we can choose between our local or our own cloud drive. I'm going to choose our local drive, which means your desktop. The maximum concurrent jobs are how many jobs you would like to be run at the same time. Your maximum failed jobs until CMOS stops running other cases is 25. Number of cores per local job. Since it's a simple model, I'm going to leave it at 1. And the maximum runtime per one job until CMOS leaves it or considers it as a fail, I'll set it as 1. And over here we have a table where for different statuses you can choose what would you like CMOS to do. So for example, normal termination, in our case, we're going to clear a job record, delete our .dat file and log file and SR3 file so that we don't use a lot of space on our local drive. In our experiments table, remember that we used KV-KH ratio that we defined in CMOST. So if you right click here and go to resolve reuse pending, resolve selected experiments, and click on the value and click OK, you're telling CMOS that you would like that parameter to be reused when doing the runs. Lastly, now that we have everything ticked, we can run our sensitivity analysis. Click OK for a local drive. It's also important to know that launcher should be opened in the background so that you can run your study. Now that our cases are done, we can look at the results and analysis by going under results and analysis to objective functions. Under objective functions are proxy analysis for each of our objective functions. For instance, cumulative oil production, we can quality check our model. In this case, all the points fall fairly close to the 45-degree line, indicating that the proxy model is matching the simulation results accurately. Okay? The verification runs, or the verification experiments, were not used in the creation of the response surface, but fall fairly close to the 45-degree line as well. This indicates that the proxy model has a fairly good predictive capability. You can also go to statistics to see your different statistics, such as for R squared, the closer it is to 1, the better match that we have. For effect estimates, we can have a tornado chart where we can see, for instance, if we change permeability H from 0.18 to 0.3, we would have an increase in cumulative oil production by 7,166 to the power of 4 meter cubes. And if we have a negative value for cumulative oil, that means if we increase it, we would decrease our cumulative oil. If we increase our parameter. Okay, and this would be the maximum amount we could increase and the minimum. Moving on to our Morse analysis. Our Morse analysis shows a relationship between our standard deviation and our mean. So for our standard deviation, shows how much of an effect do parameters have on each other, and how much for our mean is how influential that parameter is to our objective function. So for example, in the case of 3, it will be relatively not influential towards our objective function and will not be impacted by other parameters. Whereas, for example, 4 would be very highly influential towards our objective function, but at the same time will be unaffected by, or relatively affected less by the other parameters. In this case, 4 would be permeability H. Okay? And our solvable analysis shows our variance for each parameter towards the total variance. In our proxy settings, moving on to our proxy dashboard, we can generate different proxy models, our polynomial regression, a neural network, objective function proxy. And under fundamental data series plots, we can select the plots that we would like to see, which are our objective functions. And with that, we can see the difference in our proxy models with respect to our simulation data. Okay. So we can also do is what we also can do is untick those proxy models and use our what if scenario. So for instance, if I were to go to any case 13 or scenario 13, it would show me down here the parameters that were used in that scenario. And in our what if scenario, we can change our parameter value and see its effect on that respective objective function. And you can add the other objective functions up here. In this case, we only have 2. So you can see the effect of both of them, of each parameter on both of them. Moving on to our experiments table. Our experiments table show how many scenarios were created, and for each scenario, what value for each parameter was used. All right. At the same time, you can see your values for your objective functions, and you can filter them, for instance, from highest to lowest. And with that, this will be the end of the video. Thank you for tuning in, and hope to see you in another video. Thank you very much.